Let's solve day 20 of Advent of Code 2024. So today we have race conditions. We have a racetrack that has one single way that is twisting through the maze, and that single way that you can get from start to end, basically. And because it would be quite a boring race if you were just going through a very simple maze that has one single way through, they allow cheating. So when you start a cheat, you are able to pass through a wall. Basically, you disable collision for up to 2 picoseconds, and 1 picosecond is one move. So when you disable it for 2 picoseconds, for example here, you can pass through this wall. So 1, 2, and you end up here. So you have to start the cheat before a wall, then go through a wall and end up on a new empty tile that is also empty. So basically that's the idea behind cheating. And our assignment is to find how many cheats will save us at least 100 picoseconds in our own input. But in this example, there's this list which tells us how many picoseconds we can save with various cheats. So what I will do is I will use this sample input first and use it as a sample for my solution here. So let's try to do this. So I will have private int width, private int height. We'll, as usual, read in the map. So I will have private int, actually int this time, so map. And the reason why I'm using int is so that I can track the number of steps on the path for each of the empty tiles. So lines equals wait read all lines, and then we will do height width, and then we will go through the map. So create the map and do exactly this. So if it's this character, then we do -1, otherwise we do 0. And if we have starting position and position, so, point start, point end, we'll do point start equals if map x, or rather lines y x equals s, we start and end is e, right? Okay, so this way we get starting and end point, and we find distances start end. So this method will fill in distances of individual points on the map, of individual empty points on the map from the start to the end. So private void find distances, point start, point end, and we will do the following. Current point start, and there is only one single path, so we don't have to even queue things. We can do just while current point was not equal to end, and we will make sure that the map on point initially the values are 0 everywhere, so it's okay. And now next for each direction in directions without diagonals, we'll do next equals current point plus direction, and if next map next not equal to is is equal to 0. If it's still not visited, then we do current point equals next, and we also mark it as this value, like current point plus 1. So map next x, next y, and the same here. Okay, so we have current point x, current point y. So this way we kind of fill out the path, the distances for individual points on the map. And when we are done here, we just break, because we found the one direction that is actually valid for this point. And we continue with the next one. Okay, so we have now the distances, and now given the distances, we know that to save a given number of picoseconds, we need to step from a tile that has a specific number of picoseconds to another one that's distance that has a value of the at least the number of picoseconds that we want to save plus the number or the size of the path that we want to save. So basically, let's see how many. Let's save here and save how many picoseconds. Let's test things on 12 here. We want to save 12 picoseconds, and let's can save, or rather, can saves to string. We'll just return it. So this method will count the ways we can save, or count cheats, right? Cheats. Cheats. And they said the cheat is uniquely identified by its start and end point. So we'll do point start, point end, something like this. So this will count the cheats that are possible. And now we will go through the maze, and from each position we try to find all the possible ways we can get to a position that has the given number. They will save us the given number of steps. So y equals 8. So now we try to find all the possible paths. So to valid distances. So from start, we'll cheats from a given start. When we find them, then we store them in the cheats at range. Okay, or we can actually do this cheats and add them directly. So this private void method find cheats will have a starting point or start, and we'll have such set of this. All right, wait. Yeah, we actually, the uniquely identified by the start position, end position. So the start is going to always be unique because we have a unique start here. So we can just add to the list. So cheats. We have the list of cheats. Or actually, even what we can do is just count the cheats. So 0 and plus equals find cheats or count cheats from the start. So we have overload of the method with element point. And now what we do is cheat time is 2. So we have 2 picoseconds to move. So now we try to find all the locations that we can get to in 2 steps. So we start with 0 and we will do q count greater than 0 and we dequeue. So position steps current dequeue. So if set targets, so this will be our unique targets. So if actually, let's see, can we stop moving after the no, it's not clear here, so I will just make sure if the steps equals cheat time, then we check if so if we move from a position like here to here, what we save is this distance minus the cheat size, right? So we take map start minus map position minus map start. So that's the distance between them minus cheat time. So minus so x position y start x start y. So if it's greater than, we add that position to targets. Targets add position. So that's that, and return the number of targets. Now for for each of the positions without diagonals, we try to move. So we move in a direction, we check if it's within bounds, and then if it's not a wall, actually we can walk through walls in this case, so that's okay. So we have to end up on a tile that's not a wall, so map position x, position y equals, not equals to wall. We enqueue the steps, and we should be ending on, we will enqueue the next tile with the number of steps that we have. Okay, so we only need to check for boundaries, but otherwise we are okay. So that's it, I think. So now we count the cheats and return the number of cheats that we found, and that should be it. We'll see. I'm expecting some kind of -1 +1 issue here in the comparison, but we'll see. So day 20. So this is something is going forever here. Right. We never stop here. So if it's already greater than the cheat time, then we continue, or greater than equal or to cheat time, we continue. Otherwise, we try the next step. So we don't want to step forward more than the length of the cheat. Okay. So something is still happening here. I'm expecting some. Oh, here. Okay, so we have a problem here. Okay, so that is surprising. A little bit of a problem in the beginning. So until we are not at the end, so it is there. We find the next step, so that's okay. We should find one of them is correct. You set it the next. So you have the map, everything is 0, 1. Okay, so 1. The current point is now 1, 3. So what is the problem there? So it gets stuck in some kind of position. Position 1, 3. 1, 3. Because why? This is 0, no? So what am I missing here? Map 1, 2, 1, 3. Okay, 1, 3. Okay, interesting. What am I doing here wrong? It must be something basic. Okay, 1, 2, 1, 3. We start in 1, 1. Okay, wait. 1, 3 is the beginning, so how did I get back to the start? That is weird. Okay, I'm missing something very basic. It's gonna be very embarrassing, but 1, 3. So 4, 1, 2 is the next one. So I'm going up from 1, 3, setting it to 1. And now the next point is, the point that I'm processing is 1, 2. So for 1, 2, we're going plus, wait, I see. Oh, I'm going back to start. That's it. Okay, that is it. So we need to make sure that next is not equal to start, because start has the number 0 on it. So essentially we would go back to it. We could solve it more efficiently by setting start to 1 initially, but whatever. This should work as well. So 337 is the result, which is way too much. Overall, it's like a huge number. So what is off there? Okay, so yeah, of course, we need to make sure that we are starting from a valid place. So if map is not equal to -1, we cannot start from a wall. So that is one problem. Yeah, it is better, but still quite a bit too much. So starting from a point in the count sheets, and now we dequeue the number. So its sheet time is 2, and we start at position 0, 0, which, how can we start at 0, 0? Zero, 0 is definitely a wall. So what is happening? Oh gosh. 0, 0 is -1, right? So how can the start position be 0, 0? I'm doing some very basic mistakes here. Did I stop the program? Yeah, I think so. So what is happening? Start is 0, 0. Again, I inverted the condition, so it has to, if it is equal to -1, we continue. That should be better. So now it's 8. It's 8 now. So 8 is a lot. So that's way too much. So let's see. If you want to save 64 picoseconds, we should have just one way to do it. So let's see what it says. One way to do it. Okay, that's okay. So 20 picoseconds, it should be three ways to do it. So 20 picoseconds, 3 ways to do it. There's 5 ways to do it. So what are those? I'll put a breakpoint with targets count greater than 0. So there is 2, 7, 9, and 5, 7 from 7, 7. So 7, 7. So this is 7, 7. So from here, this will save us. So from here to 7, 9 and 5, 7. So 5, 7 is the end position, right? That's 5, 7. And 7, 9 is going through this wall here. That seems okay. Maybe that's a condition that's problematic, I think. Let's see, if I add it here, we want to save 20 and we save 40. That's towards 7, 9 from 7, 7. 7, 7. One sheet only, okay. Oh, I see. This is kind of grouped by, so this saves, this means 5 is the right result for 20, actually. Okay, that makes sense. So now we check it, it's gonna be 5, okay. And how many cheats would save at least 100 picoseconds? So let's see if I set this value to 100. We'll see what happens. So in this case, it would be 5. Wait, what? Oh, at least, it's in this example. So maybe we can verify on 10 picoseconds. That would be a good measure. So 10 picoseconds. That would be like 5 plus 5, so 10. So 10 should be the result, and that is correct. Okay, so we use a full input and run it on with 100 here. So we'll see what happens. Okay, we have downloads, input, and run 1518. Okay, that's the right answer. So we have the first part solved. Now let's go to the second part. So now the new rule of cheating permits a single cheat that lasts for 20 picoseconds. So we can extend our journey through the maze this way. And we can verify it again on the sample input. But the idea should be basically just to edit the cheat time here, and it should hopefully work. So let's try it. So now instead of a cheat lasting for 2 picoseconds, it's going to be 20. And we want to save, let's try it on the sample input, so we will want to save 74. So that should be 7 different cheats. Okay. Now we're getting into some problems there because we are trying way too many things in here. Yeah, so this doesn't work because we just enqueue way too many things. And we want to know where we can end up in those 20, that number of steps that equals the number of the cheat itself. So we need to find everything that's at most the number of steps distant. But also we need to make sure that if we walk and they make the movements, we can actually end up on that tile after the number of steps. So if it's like even, we can do 1, 2 steps, but we cannot do 1, 2, 3 steps because we couldn't end up on the same tile this way. So yeah, okay, let's change this. So we will do y with height for x width. All right, let's do this. And distance. So we will calculate the Manhattan distance from the point to this one. So if start x minus start x minus star end. So minus x plus start y minus y. So we calculate the distance and see if it's greater than cheat time. Then we skip it. But if it is within the cheat time, we can get there as long as the distance is it has the same. If the distance is compatible with the number of steps that we need to take. So distance if we are doing 2 steps, we would have to do 1, 2. So the distance, if the distance has the same modulo by 2, if distance modulo 2 equals cheat time modulo 2, then we can actually end up there by walking. So we calculate if you've saved enough. So and if the map x y is actually greater than or equal to 0, then we check if we improved things, or greater than 0 basically. If we improved things, and then we add it to the targets that we can pick. So this will speed up things significantly. Right. Three is the number that we got, and we should be getting, or yeah, maybe it's just that I'm not checking this correctly. So this is the step time. We want to save 74. Cheat time is 20. Oh, I see. That's the problem. So I did notice this rule that the cheats don't have to use all of those 20 picoseconds. So I can actually get rid of this condition. And that should be the problem, hopefully, that I was facing. So now, if I run it again, hopefully it will work. 7. Okay, that's better. So now let's do 100 and test it on the actual input. So we want to save 100. Cheat time is 20, and let's run it. Right. This is the result. And it is correct. All right. So we solved day 20 of Adventive Code. So I caught up on what I missed during vacation. So looking forward to day 21. Thank you for joining today's session, and I will see you tomorrow.